Okay, so this is question number 1 on the chapter 22 homework. It says in the figure, the electric field lines on the left has twice the separation as those on the right. So you can kind of see that the electric field, basically, this is twice as close as this one over here. So part A asks, if at point A we put a proton, what would the magnitude of the force be on that proton inside of that field? So the equation I'm going to use is force equals the charge times the electric field. So in this case, the charge that I'm going to be using is the charge of a proton, which is positive 1.6 times 10 to the negative 19 coulombs. And then the electric field that we're going to be using will be this value right here. So that'll just be 39.0 newtons per coulombs. It's important to notice that the field is going this way. So I'll kind of draw myself out a little axis here. Call that positive, that positive. So this direction would be the negative I direction. So when we plug this into our equation, our force will be equal to 1.6 times 10 to the negative 19 coulombs. And then 39.0 newtons per coulombs. And this will give us, let's see here, I believe, 6.24 times 10 to the negative 18 newtons. And I mean, it was asking for the magnitude, but if we wanted the direction, it'd be in the negative I direction, just because we see that that's the way that the force is going. The second part asks, what is the magnitude of the field at B? So on this part, what you can kind of see, since the separation is double, I can write myself out a little equation. So we'll call all of this area like field A. We'll call this area like B. And so in this case, EA will be equal to 2EB. So EA, EA will be the 39. So if we want to solve for EB, what the electric field would be over here, I'm going to just plug in my number. So 39.0 newtons per coulombs again equals 2 times EB. So then this field over here will be 19.5 newtons per coulomb. And so that's how you do question number 1 on the chapter 22 homework.